Hi everyone. Well, what you see on the calculator is the equation, or the graph of the equation y equals cosine x. As you can see, it is a function. A vertical line, if you think of the vertical line test, it will hit at most one place on the graph. A vertical line will touch at most one place. I should have thought this through before I did that. But if a horizontal line were drawn, well, you can look at the axis there, the x-axis, you can see that it'll hit multiple places. So the inverse of y equals cosine of x is not. Well, the inverse function if you'll recall, is y equals the inverse cosine of x. Y is actually the angle, x is the values for cosine. Well, the values of cosine only will go, the values that you can get for the cosine, you can't be bigger than 1. You got to be bigger than -1 also. They only go from -1 to 1. And if you'll look at the cycle here, -1 to 1, look at, I'm only going 0 to pi, and then it'll cycle over again. I set zoom standard, and every pi over 2 is marked here. So 0 to pi. So I'm going to set this window and graph the inverse. And just take a look at what that is. Let's see, change the function, second cosine, window, let's go x from -1 to 1 by 1s, and let's go min value of 0, max value of pi, there we go, and go by pi over 2. Okay. Let's extend that out a little bit to the left and the right, up and down, because you've captured the window here completely. But if I go -1.5 on the x and +1.5, and if I go let's do y min of -1 and y max of 4.14. Just add 1 to 3.14 and look at that graph. You can see it just stops there. So that curve is all there is to it for the inverse cosine. We restrict ourselves between 0 and pi and 1 and -1. Well, let's deal with the inverse trig functions here. Let's say I want to know what the inverse cosine of 1/2 is. In other words, what angle has a cosine of 1/2? We're going to restrict ourselves between 0 and pi. I think if you look at your unit circle and you look at 1/2 for the x, you're looking up here, and I think you'll see that y is equal to pi over 3 when that happens. What if I want to find the inverse sine of negative 0.9 in radians? We'll do everything in radians. If I want the inverse sine of negative 0.9, uh-oh. Let's see if I can salvage this, guys. I wasn't relying on that very much. Okay. Let's quit out of that. Second sine of negative 0.9, I'm getting negative 1.12 to the nearest hundredth radians. Let's try one that's on the unit circle. The inverse sine of negative radical 3 over 2. If you think about that, negative radical 3 over 2, so it'd be up kind of high here. If you're looking at that, that is, I believe, 7 pi over 6 at this point right here. In addition to that, I could look right here and I could go in this direction, and that would also equal negative pi over 3. So the fact that one value can give you more than one value here says that that is not a function. What is the calculator rounded to? Which one would the calculator give us? Well, let's look. Inverse sine of negative square root of 3 divided by 2. Negative 1.04, it's given us that one right there. All right, so probably going to be restricted to this. We won't give that one. We'll just stay in between negative pi over 2 and positive pi over 2. Let's take a look at another example. Let's combine them. The sine of the inverse cosine of 3/5. Well, if I look at a right triangle and have this angle theta, that theta has a cosine of 3/5, which is adjacent over opposite. I'll bet if you look at 3 squared plus 4 squared plus 5 squared, so the sine of that angle theta here, which I don't know the angle, we could look it up if you wanted, but the sine would be the opposite over the hypotenuse, which would be 4/5. Let's try another one. Let's take the sine of the inverse tangent of the tangent of pi over 6. Well, what do you think the inverse tangent of the tangent does to each other? Yes, it will cancel each other out, and that's basically the sine of pi over 6. And if you look at the sine of pi over 6, pi over 6 is over this way, you're looking at 1/2. I will close with that, and we'll do some more practicing tomorrow. Let me see these notes, and we will get to it.